Search for terms like stress and brain online, and you'll quickly stumble into corporate workshops and self-help courses warning you about something called the amygdala hijack. The story goes like this. Tucked deep inside your brain is an almond-shaped relic from our evolutionary past. It acts as a strict gatekeeper for your emotions. When stress hits, this primitive node reportedly disables your conscious, rational mind to let pure animal instinct take over. It is an incredibly appealing idea. Blaming a rogue piece of anatomy provides a neat, scientific-sounding excuse for why we lose our tempers, snap at our coworkers, or panic under pressure. But this logic creates a paradox. If the amygdala really is a hijacker that suppresses our higher reasoning, then physically cutting it out of the brain should theoretically leave a person perfectly rational, entirely conscious, and immune to impulse. To see if that's true, we have to look at the medical records of what actually happens when the brain's emotional center is physically destroyed. In the 1930s, researchers Heinrich Klüver and Paul Bucy were working with a famously aggressive and unruly rhesus monkey named Aurora at the University of Chicago. To understand certain brain functions, surgeons physically removed her left temporal lobe, which is the region that houses the amygdala. When the researchers checked on her the next day, Aurora was entirely tame and docile, showing none of the hyperrationality the hijack theory would predict. Klüver and Bucy described her new condition as psychic blindness. Her physical eyesight was perfectly fine, but she could no longer evaluate whether the objects in front of her were good, bad, or dangerous. Without that internal valuation system, she approached threats without hesitation. She began compulsively putting random objects into her mouth, like a human baby, ate whatever was in front of her, and displayed a marked increase in indiscriminate sexual behavior. Removing the amygdala didn't free Aurora's conscious mind from animal instincts. It stripped away her ability to assess risk, safety, and meaning in her environment. We see similar outcomes in human medicine. For decades, neurosurgeons have treated severe epilepsy by cutting out the unstable brain tissue where seizures begin. Often, this means removing parts of the temporal lobe and the amygdala along with it. Patients who undergo this procedure often struggle to read negative emotions like sadness or fear on other people's faces. Their social interactions break down, and some exhibit the same severe hypersexual disinhibition seen in Klüver and Bucy's monkeys. In one documented case, a 51-year-old man had his temporal lobes operated on twice to treat persistent seizures. Following the surgeries, he lost his behavioral cruise control. He developed a sudden, unquenchable obsession with pornography, which escalated into downloading illicit material involving children. When he was eventually arrested, his doctors argued that the surgical damage to his temporal lobe directly caused this behavior. This forced the court into a difficult dilemma. How do you assign legal guilt to a person whose neurological braking system has been physically dismantled by a surgeon? These tragic human anomalies reveal that the amygdala provides the very system required to temper and regulate our base instincts. To understand how that regulation actually works on a microscopic level, we can look at the experiments of neuroscientist Joseph Ledoux, who mapped the firing pulses of amygdala cells in rats. The setup was straightforward. A rat hears a sound of a specific pitch, and immediately after, it receives a mild, unpleasant electric shock through the floor. This diagram illustrates what happens during that test. Over time, the rat learns the association. Synapses strengthen to encode fear, generating the rapid spikes you see here. Think of a synapse like a hand gripping a branch. Before learning, the grip is weak. After learning danger, the grip tightens. This physical reinforcement makes the amygdala a powerful association engine. This physical reinforcement also applies to rewards, like the way we learn to assign value to a simple $20 bill. Once you learn that handing over this specific piece of paper results in pleasant outcomes like a hot cup of coffee or a meal, your amygdala physically strengthens the connections associating the paper with those rewards. The amygdala is essentially a comprehensive emotional stock market. It constantly receives data from your senses and tirelessly weighs the value of everything we encounter to determine what is worth our attention. We know this because of rare modern cases like patient SP, a woman whose epilepsy treatment required the removal of her right amygdala, while her left amygdala was already damaged. Despite this, her memory and cognitive functions were intact. In a conditioning test, researchers showed SP a blue square, followed by a shock, represented by this spike. Normally, the body anticipates this with a fear spike, but for SP, the metrics remained completely flat. Her body did not react. Yet she wasn't completely oblivious. When the researchers asked her what was happening, she explained perfectly that whenever she saw the blue square, she knew the shock was coming. Her conscious mind understood the threat, but without an amygdala, her brain couldn't generate the subcutaneous physical feedback that actually makes your body feel afraid. Clinical evidence dismantles the hijacker myth. The amygdala acts as a vital hub, signaling what matters, while our conscious mind remains entirely intact even without its emotional engine.